There's this really incredible story about a 5-year-old boy named Noam.
Oh, right, the drawing.
Yeah, exactly. So he's sitting in his first grade classroom, right?
Mm-hmm.
And he actually looks out the window and witnesses the very first passenger plane crash into the World Trade Center on 9/11.
Just completely unimaginable for a kid.
Totally unimaginable. But the very next day, he sits down with his crayons and draws a picture of what he saw. So he draws the burning buildings, he draws the smoke, and he draws people falling.
Right.
But right at the bottom of the buildings, he draws this giant trampoline to save them.
Wow. And that little detail, the trampoline, it actually reveals something really profound about human neurobiology.
How so?
Well, even though it was just in his imagination, Neuron was able to take action, right? His brain processed this absolutely terrifying event, but he gave it a protective, active ending.
He didn't just freeze.
Exactly. And doing that actually prevented his nervous system from getting permanently stuck in this state of absolute helplessness.
That is just wow. Well, welcome to the Deep Dive. Today we are exploring the physiological mechanics of extreme stress. We're trying to answer a really profound question for you today, which is, does trauma really get stuck in the body?
Yeah, it's a huge topic.
It is. We are going to unpack how deeply stressful experiences impact your nervous system. And I want to be clear right up front, we are doing this strictly through the lens of neuroscience and clinical data.
Right. We are definitely not diagnosing anyone here.
Exactly. No diagnosing. So what are we actually looking at today?
Well, we're breaking down what actually happens to our internal hardware, when we are pushed way beyond our biological limits. We really want to understand why feeling physically or emotionally trapped where that normal escape route is just blocked is often the defining factor that leaves our internal alarms ringing long after a threat is gone.
Right. And to get to the bottom of this, we've pulled a really diverse stack of sources for this deep dive.
We definitely have.
We are examining some excerpts from Dr. Bessel van der Kolk's incredibly popular book, The Body Keeps the Score. But because we need a balanced picture here, we're weighing his perspectives against a major peer-reviewed critique.
Yeah, this is the one by Dr. Michael S. Scheringa from the BJ Psych Bulletin, right?
That's the one. He pushes back hard on some of these modern trauma narratives. And we'll also be digging into some clinical data, including a major prospective study from Duke University looking at baseline brain vulnerabilities and a recent PLOS study analyzing somatic interventions.
So our mission today is really to cut through all that heavy medical jargon, right? We want to objectively weigh this conflicting scientific evidence for you.
Because it can get pretty dense.
Oh, absolutely. We want to figure out, how much of this is actual structural brain damage, how much is just a reversible software glitch, and what the latest research actually says about hitting the reset button on your nervous system.
And we'll wrap up with 3 practical takeaways for your everyday life. So let's just jump right into the biological mechanisms of feeling trapped.
Let's do it.
To understand why someone's nervous system gets stuck, we really have to look at how extreme stress completely reorganizes the brain's internal alarm system.
Right, because the brain is essentially organized sequentially. You have the primitive reptilian brain at the very base, and that handles your basic survival functions like heart rate, breathing, stuff like that.
The automatic stuff.
Exactly. And then at the top, you have the highly evolved neocortex. That's your rational thinking brain. But in the middle, we have the limbic system, which is basically our emotional command center.
And the key player in that system is the amygdala, right?
Yes, the amygdala. It functions as the brain's rapid response smoke detector.
I love that analogy.
It's super accurate. Its sole job is to rapidly detect danger in the environment. And when it senses a threat, it doesn't wait for your conscious permission. It just instantly pumps adrenaline and cortisol right into your bloodstream.
But then right behind your forehead, you have the medial prefrontal cortex, or the MPFC, which the sources refer to as the watchtower.
Right. So in a normal, healthy stress response, that watchtower looks down and evaluates the alarm.
So if we think about an everyday situation like an office worker in Bangkok, right?
Okay, yeah.
Say the office fire alarm goes off because someone just burned toast in the pantry.
Happens all the time.
Right, so the smoke detector, the amygdala, goes off. But the watchtower looks down, sees the burnt toast, and modulates the amygdala. It basically sends a biological, all-clear signal, calming the nervous system back down to baseline.
Exactly. But in traumatized individuals, this delicate balance is just radically shifted. The watchtower is essentially asleep.
Which brings me to the brain scans mentioned in the van der Kolk source. There was this study involving a patient named Stan who had been in a really severe car crash.
Oh, right, the fMRI study.
Yeah. So they put him in the scanner and played an audio script recounting his accident. And from a neurological standpoint, Stan didn't just remember the crash. His amygdala lit up like a Christmas tree.
It was signaling a massive, present-tense biological emergency.
Right. But what really stood out to me was what happened to the left hemisphere of his brain.
Yeah, that part is wild. The scan showed his left brain, specifically the areas responsible for logic, language, and keeping track of linear time, it just shut down completely.
It just went totally offline.
Completely. So from a biological standpoint, Stan's brain temporarily lost the capacity to recognize that the event was in the past.
Because when the amygdala detects what it thinks is a mortal threat, it doesn't, consult a calendar.
No, not at all. It assumes the threat is happening right now, so the rational brain goes offline. When that smoke detector goes into absolute overdrive, the watchtower is evacuated.
So the logical thought required to just say, hey, I am safe in this medical scanner, it becomes physically inaccessible to him.
And if we map this mechanism onto everyday life, it explains a vast array of seemingly disproportionate behaviors.
Like what?
Well, think about that same Thai office worker. They might completely freeze up if someone just accidentally bumps into them on a crowded BTS SkyTrain commute. Or they might blow up in a total rage over, a minor passive-aggressive email from their manager.
Because the smoke detector is misinterpreting a totally safe annoyance as a life-threatening scenario.
Exactly, because the watchtower isn't functioning to supply the necessary context. The context is gone.
So if that panic alarm is just constantly ringing, but there is no actual fire to put out, all that mobilized energy has to go somewhere.
Yeah,
right?
and the sources suggest it goes straight into the physical body.
But I want to contrast Stan's fiery panic with another patient in that same study, a woman named Ute.
Oh, Ute. Her reaction was the complete opposite of Stan's.
Right. So they play her trauma script, and her scan demonstrated this profound biological shutdown. Her amygdala didn't light up with hyperactive fear at all.
No, instead, her scans showed decreased activation across almost her entire brain.
Which is just terrifying in a different way.
It is, because when the nervous system realizes it can neither fight off a threat nor flee from it, it deploys this evolutionary last resort defense mechanism.
Yeah.
That's dissociation.
It's like an extreme biological freeze response.
Yeah.
You basically blank out to protect yourself from unbearable psychological or physical terror.
You dissociate so you don't feel anything.
And this brings us to a really fascinating part of the brain called the insula.
The insula is so important here.
It integrates all the signals from your internal organs, your muscles, your joints. It's the literal biological source of your gut feelings, right? It's your sense of being physically embodied.
And in trauma survivors, the insula often shows highly abnormal activation. Because, think about it, when your body is constantly bombarded by terrifying warning signs, a racing heart, tense muscles, shallow breathing, the brain eventually just learns to numb its awareness of those sensations.
It's an incredibly effective short-term survival adaptation.
It is, yeah. The long-term side effect of that adaptation is a condition the gorillas call alexithymia.
Right, which is a Greek term that literally translates to no words for feelings.
Exactly. Because if you suppress the physical sensations of your body just to survive, eventually you lose the ability to identify your own emotions.
So you might be red in the face with your jaw clenched super tight, but genuinely deny that you're angry.
Right, because you've severed the internal connection that reads those physical cues.
You know, this mechanism really reminds me of, imagine a smartphone that is just buzzing with 1,000 urgent Line app notifications.
Oh, that's a good analogy.
Right.
Yeah.
But the screen is completely smashed, so you feel this frantic vibration in your pocket, and it's giving you a stomachache and tension in your shoulders because it just will not stop buzzing. But you cannot read the messages to know what the underlying emergency actually is.
That is exactly it. The physical tension is the vibration. The physiological arousal is there, but without the screen to provide a narrative context, it's just pure, terrifying chaos.
And because people can't read those internal messages from their own bodies, they understandably turn to external methods to manually silence the vibration.
Yeah, they might overwork to the point of total burnout. They might rely heavily on substances like alcohol or engage in high-risk sensation-seeking behaviors.
Just to assert some false sense of control over the internal chaos.
Or simply to feel something, anything other than that baseline of dread.
The physical toll of carrying that unresolved energy is just massive. The sources talk about chronic muscle tension that cascades into conditions like fibromyalgia, chronic fatigue syndrome, severe migraines.
Irritable bowel syndrome, autoimmune issues, the list goes on. The body is just in a state of perpetual bracing against an invisible threat.
Okay, so if the alarm is constantly going off and the screen is completely smashed,
Yeah.
it sounds like the hardware is just permanently fried. I mean, hearing about all these altered brain structures, the hyperactive amygdala, the shrunken hippocampus, the broken insula, it is really easy to conclude that extreme stress permanently damages the brain.
It is easy to conclude that, yeah.
But I want to pivot to the critical pushback in our sources here. Is the brain actually damaged, or is it just stuck in a bad software loop?
This is where we have to bring in Dr. Michael Scheringa's peer-reviewed critique of these popular trauma narratives.
Right, because he reviewed, what, over 100 specific claims?
Over 100 claims from books like The Body Keeps the Score. And he argues that while the metaphors of permanent physical change are culturally really compelling, the underlying science is actually highly contested.
I was reading through his methodology critique, and he really targets the timeline of these neuroimaging studies. He points out this glaring chicken and egg problem.
The cross-sectional study issue.
Yes. Wait, can you explain what cross-sectional actually means for us?
Sure. So many of the studies showing, say, a smaller hippocampus or a hyperactive amygdala in traumatized individuals are cross-sectional. That means researchers only scanned the brains after the traumatic event had already occurred.
Oh, I see.
Yeah, it's essentially just a snapshot in time. It tells us that a group of people with PTSD has structural brain differences compared to a control group without PTSD.
But it violates a fundamental rule of scientific research, right?
Yeah.
Correlation does not equal causation.
Exactly. You cannot definitively prove a traumatic event caused a brain structure to shrink if you never measured its size before the event occurred.
And this is where that Duke University study totally reframed my understanding of this entire topic, because researchers there didn't rely on cross-sectional snapshots. They looked at prospective data.
Which is much more reliable.
Right. They took brain scans of individuals. They used military personnel and first responders before they were ever deployed into high-stress environments. And then they tracked their psychological outcomes over time.
And that prospective data flips the dominant trauma narrative completely on its head.
It really does.
The Duke findings strongly suggest that the structural brain differences like a smaller hippocampus or higher baseline amygdala reactivity, they were already present before the trauma ever occurred.
So they are pre-existing vulnerabilities, not the result of permanent structural damage inflicted by a single event.
Exactly. In psychology, this is known as the diathesis stress model.
So, to use our earlier analogy, the smoke detector might have naturally been a little more sensitive from birth, or the watchtower guard might have naturally been a heavier sleeper.
Yes. The traumatic event just exposed the vulnerability in the system. It didn't necessarily build a faulty, broken system from scratch.
That makes so much sense. But Scheringa also pairs this structural critique with a warning about a cultural phenomenon he calls neurorealism.
Oh, neurrealism.
Yeah.
We live in an era where the public and even medical professionals honestly tend to give theories outsized credibility simply because they're dressed up in neuroscience jargon.
Or accompanied by really colorful fMRI scans.
Right. It makes subjective suffering feel tangible and scientifically validated.
Which is deeply seductive because it validates lived experience. I mean, being told, hey, it's not all in your head, it's literally written into your biology, that is an incredibly powerful destigmatizing message for someone who has been suffering with invisible psychological pain for years.
The validation is absolutely important. But Scheringa argues that neurorealism can inadvertently create this deterministic, hopeless narrative.
How so?
Well, if you internalize the belief that stress has fundamentally and permanently damaged your brain, that the score is irreversibly etched into your physical tissues, you might feel broken beyond repair.
Right, like there's no fixing it.
Exactly. The physical suffering is entirely real, but the scientific explanation we use to frame that suffering really dictates the treatment.
Because if the explanation is permanent hardware damage, you are essentially stuck managing symptoms forever. But if the explanation is a pre-existing vulnerability compounded by a softer loop,
then that opens the door to neuroplasticity. The brain can learn, it can adapt, and it can rewrite the software.
Which leads us to our next crucial question. If the brain isn't permanently broken, how do our sources say we actually fix this glitching alarm system?
Right. So the clinical data presents two main and sometimes highly debated paths to healing. You have top-down interventions versus bottom-up interventions.
Okay, let's start with top-down.
Top-down healing involves using the rational brain, the prefrontal cortex, to consciously process memories and eventually send calming regulatory signals down to the amygdala.
So this is your standard cognitive behavioral therapy, or CBT. You engage the watchtower.
Exactly.
You talk through the experience, you safely expose yourself to the memory, and you rationally challenge the fearful thoughts until the brain finally learns that the memory belongs in the past and there is no current danger.
And according to Sharinga's review of decades of literature, structured top-down approaches still yield the most robust, durable outcomes in large-scale randomized controlled trials.
So the clinical efficacy of CBT is undeniable.
It is. But researchers like Kolk argue that you cannot always logic your way out of a physiological panic attack.
Right, which introduces the bottom-up approach. This bypasses the cognitive brain entirely and engages the physical body directly to change the state of the mind.
Yes.
But I want to dive into the mechanism of how that actually works because it sounds a bit abstract. We just talk about like taking deep breaths.
Well, we are talking about neuroanatomy. So consider the vagus nerve.
Okay.
It's the primary nerve of the parasympathetic nervous system, which controls rest and digestion. A massive proportion of its fibers are afferent.
Afferent meaning?
Meaning they send signals up from the body's internal organs to the brainstem, rather than the brain dictating commands down to the body. Up to 80% of the vagus nerve's traffic is heading north.
Wait, really? 80%. So the body physically tells the brain it is safe, not the other way around.
Yes. And this ties directly into polyvagal theory, which our sources explore. It suggests our autonomic nervous system has 3 distinct operational gears.
Okay, what are they?
You have the ventral vagal gear for social engagement when you feel totally safe. You have the sympathetic gear for fight or flight when you're stressed, and the dorsal vagal gear for the freeze response when you are completely overwhelmed.
And polyvagal theory posits that you cannot jump straight from a profound state of biological freeze back into rational social engagement.
No, you have to physically regulate the nervous system to shift the gears. If you consciously slow your breathing or engage in mindful physical movements, you stimulate the vagus nerve.
And that nerve sends a biological signal of safety up to the brainstem.
Exactly. It essentially whispers to the amygdala, hey, the physical environment is secure. You can turn off the alarm.
Let's look at that PLOS study to see this in action. Because researchers studied Indonesian women who were survivors of severe, complex trauma. And they didn't rely on traditional talk therapy at all.
Right. Instead, they utilized somatic experiencing, which is a quintessential bottom-up intervention. Somatic basically meaning relating directly to the body.
And the researchers noted that top-down verbal therapies demand an immense amount of cognitive load and executive functioning.
Which is hard when you're traumatized.
Exactly. In contexts where language fails, or when recounting a narrative immediately triggers a flashback that knocks the watchtower completely offline, talking becomes counterproductive. It just reinforces the panic loop.
So by using somatic interventions, guiding the patients to feel their feet firmly on the ground, tracking areas of physical tension, regulating their breath patterns, they help these women befriend their physical sensations again.
They biologically reduce the physiological terror without forcing them to verbally process the entire traumatic narrative right away.
It's a method of circumventing the broken screen.
Right.
By manually lowering the heart rate and releasing the bracing muscle tension, the frantic vibration stops long enough for the screen to be repaired. And that eventually allows the prefrontal cortex to come back online and do its job.
Think about our highly stressed Thai office worker again, right? Someone on the verge of total burnout due to crazy deadlines. You can't just logically tell them, hey, calm down. This quarterly report isn't a mortal threat.
No, because their watchtower is offline.
Exactly. The top-down rational approach will fail. Sometimes you have to physically step away from the desk, go outside, feel the air on your skin, and just take 10 deep breaths to biologically reset the nervous system first. That is bottom-up regulation.
But while these body-based somatic therapies are gaining massive cultural traction right now, the critical research from Sharinga reminds us to maintain scientific rigor.
Right.
They are highly effective for stabilization, but they are not scientifically proven to be a silver bullet replacement for structured top-down therapies like CBT when it comes to long-term trauma resolution.
So the general clinical consensus seems to point toward a synthesized approach. You need the bottom-up interventions to calm the physical body so the alarm finally turns off.
combined with the top-down cognitive therapies to contextualize the memory so the brain can properly file it away as history.
You stabilize the hardware first, and then you rewrite the software.
Beautifully said.
But we've covered a tremendous amount of neuroscience today, from hijacked amygdalas to vagus nerve pathways. Which brings us to the core mission we set at the start, distilling this data down to 3 practical, everyday takeaways you can actually use.
Okay, number 1. Recognize your false alarms.
What does that look like in practice?
Well, when you experience a sudden, intense spike in anger, or if you find yourself completely freezing up during a seemingly minor conflict at work, try to recognize that it might simply be your amygdala overreacting.
It's your internal smoke detector misinterpreting a harmless present moment based on old, outdated data.
Right. Just recognizing that biological mechanism can give you a crucial moment of grace before you react.
That's great. Okay, takeaway number 2. Befriend the broken screen.
If you struggle with unexplained physical tension, chronic headaches, or even emotional numbness, that alexithymia we discussed, practice noticing your physical sensations without any judgment.
So don't try to immediately analyze the feeling, and don't try to push it away.
Exactly. Reconnecting with your physical body through simple, quiet awareness is the very first step to repairing that screen and finally reading your internal notifications.
I love that. And finally, takeaway number 3. You are not permanently damaged.
This is so important. Reject the deterministic narrative that stress has irreparably broken your brain.
Because the robust science of neuroplasticity, coupled with a better understanding of pre-existing vulnerabilities, shows us that the brain and the nervous system remain highly adaptable throughout our entire lives.
Whether you find success through top-down talking therapies or bottom-up body-based practices, healing is biologically possible. You have agency over your own nervous system.
The human organism is just built for resilience, and the past does not have to dictate the future of your biology.
It really doesn't.
Before we wrap up this deep dive, I want to leave you with one final thought to explore on your own. Right now, as you listen to my voice, take a quick inventory of your physical state. Are your shoulders creeping up towards your ears? Is your jaw currently clenched tight? If our bodies truly carry the weight of our unexpressed stress, what is your posture telling you right now that your conscious mind is simply too busy to hear?